In this video, we'll show you how to use the ReFS for Linux driver. First, let's create a ReFS volume using a Windows Server 2016 virtual machine. We're attaching our test storage with two partitions on it. And formatting the second volume as ReFS with label ReFS3. Here we have test data consisting of a pair of folders, several small files, and one large file. Let's copy this test folder to the ReFS3 volume. And create an MD5 checksum using the HashCheck plugin for Windows. The checksum of the copied files matches, so we can disconnect the test volume from our Windows Server 2016 machine. And connect it to the Windows 10 virtual machine. As you can see, Windows 10 hasn't recognized the ReFS3 volume we created on the Server 2016 platform. So let's format another test volume into ReFS on Windows 10 with label ReFS1. This Windows 10 machine also has test data with several files in Latin and non-Latin names, small files, a pair of large files, and two folders. We'll copy this folder to our ReFS1 volume and we'll create an MD5 checksum for the transferred files. Now our test storage with two ReFS volumes, ReFS1 and ReFS3, is ready and can be disconnected from the Windows 10 machine. Now let's pause Windows 10 and launch our older Ubuntu 14.04 LTS platform, which is using kernel 3.13. Now we'll unpack the ReFS for Linux package. And try to install the UReFS driver using the provided installed.sh script. Installation was unsuccessful due to lack of memory stack. Next, we'll use the newer Ubuntu 16.04 LTS Linux platform with kernel 4.8 installed. Again, unpacking the driver archive. And installing it on the platform with the script. The ReFS driver is installed successfully on the system and can now work with the UFSD driver in parallel. Next, we'll attach our test storage with two ReFS volumes, which can't normally be mounted on Linux. And we'll verify the exact hardware device via the fdisk command. First, we'll try to mount the ReFS3 volume from Server 2016 with all permissions set to everyone. It fails because ReFS doesn't yet support ReFS3. Mounting the ReFS1 volume from Windows 10 is successful. Let's go to the ReFS1 storage on Linux. And read the contents of the MD5 checksum file created on Windows. And verify the hashes of the existing files with the MD5 sum utility. Now we'll create a new file with the echo command from console. And make a few operations using folders and files. All on the ReFS1 volume from the graphical user interface. Next, we'll share the ReFS1 volume from Linux over the network using Samba. Here we're checking the IP address of the Linux machine with the ifconfig utility. And connecting to the shared folder from Windows 10. Now we'll verify the checksum of existing files over Samba, create a new folder and upload test files into it. Once again, collecting and confirming the MD5 checksum for transferred files. Let's unmount our test storage from Linux and reconnect it to Windows 10. Oops, Samba is still using it. We need to turn off the Samba service. And then try again. Success! Returning to Windows 10, connecting the test volume directly, ReFS 3 is again not recognized. And once more verifying the checksum of Samba transferred files. We have confirmed the workability of the ReFS for Linux driver with read-write support on ReFS 1.x volumes. Thank you for watching this guide.